molecular compounds. We have seen that when you have a metal and a nonmetal, an ionic bond is formed, making an ionic compound. The ions that make up an ionic compound are independent of each other. That is, they are not specifically connected to any other particular ion. Other compounds, however, are formed when two nonmetals combine. These are molecular compounds, where the atoms tend to stay together as a group that is held together very strongly. This is because the bond between nonmetals is a covalent bond. Pause the video here if you would like to write down these definitions. Remember that the nonmetals occur to the right and the top of the table, plus hydrogen, which is usually on the left of the table. This means that the atoms have high ionization energies and high electron affinities, except for the noble gases, which have low electron affinities. When two nonmetals form a bond, neither one gives up an electron easily, and both release a significant amount of energy when an electron is added. So how does this happen? There are several ways the positively charged nuclei and the negatively charged electrons interact with each other. First, there are attractions between the electrons and the nuclei of the atoms, because opposite charges attract each other. There are repulsions between the electrons, because like charges repel each other. And there are also repulsions between the nuclei of the atoms. Here's a movie which talks about the formation of the bond between two hydrogen atoms. When two hydrogen atoms come together to form a bond, each one starts with the nucleus, a single proton, and one electron. As the atoms move closer together, the electrons begin to feel the attraction to the other nucleus, and the energy decreases. After they reach a certain distance, however, repulsions between the two electrons and between the two nuclei become more important, and the energy rises sharply. So the two atoms sit at a certain distance from each other, where they have the lowest energy. Significant energy is needed to separate the atoms from each other, and the electrons are attracted to both nuclei at the same time. In that sense, the electrons belong to both atoms. They are shared. Here is a slide that shows all the important information of the movie. The numbered drawings at the top of the diagram correspond to the positions of the two atoms on the diagram. You will note that the energy goes down as the atoms get closer up to a certain point, number 3, and then it rises rapidly. So the atoms sit at the distance where the energy is lowest. This distance is called the bond length. Pause the video to write down this definition. The energy released when a bond forms, or the energy it would take to pull the two atoms apart, that is, to break the bond, is called the bond energy. Pause the video to write down the definitions. This is another definition of bond. Again, pause the video to write down the definition. So to form a covalent bond, we need two atoms that hold on to the electron strongly, that is, two nonmetals. So the conditions for forming a covalent bond are that both atoms have high ionization energy and high electron affinity. Covalent bonds are different from ionic bonds. In an ionic bond, the electrons are transferred from one atom to another. The electrons in the bond belong to the atom they have gone to. But in a covalent bond, the electrons are shared. They belong to both atoms at the same time. There are two ways in which the bonds are very similar, however. In an ionic bond, the energy after forming the bond is lower than before the bond is formed. And in a covalent bond, the energy is lower as well. In an ionic bond, the electrons are transferred until the valence shell of one atom, the metal, is empty, and the valence shell of the other atom, the nonmetal, is full. In a covalent bond, both atoms, both nonmetals, usually end up with filled shells.